So, nice to be here. I'm the CTO of Saab Dynamics, one of 4 business areas, and I'm also chairing the Saab AM Group. I'll just in a minute show you what that is all about. Saab goes additive sounds like we've already done it, but we have only started, I would say. But we're moving on the journey, layer by layer, if you will. Now, we don't do cars anymore. I'd like to make that statement first. Everyone believes that Saab makes cars. We don't do it. It's defense and security these days. So you have the most well-known part is Saab Aeronautics developing and producing jet fighters, the Gripen fighter. You have underwater systems, which is the most recent acquisition to Saab, and that is Saab Kockums, submarine development and production. You have surveillance, which do both command and control systems as well as sensors, that is radar systems for Navy, land, and air. And we have advanced weapon systems, which I represent, Saab Dynamics. And we do the things that hangs on the pylons on the jet fighter or are in the tubes of the submarine, for example. If we dive into dynamics, I will do that for a reason. I'll show you a couple of cases from there, and I'd like to show that we have 6 different portfolios within only Saab Dynamics. One example comes from that anti-ship missile hanging on the Gripen fighter on missile systems, and one from underwater systems. Now, war is a nasty business. Nobody wants it. However, we never seem to be able to get rid of it. I chose as an illustration this one here, which is from the war between Israel and Hamas, 2021, not knowing that we should have another war on our hands right now. But as an illustration, it's good because from the right here, you have the simple ballistic rockets that Hamas launched, I think over 4,000 of them in a few weeks. And those simple ballistic rockets cost under $1,000 to produce. Israel responds with its Iron Dome air defense, one of the best in the world. But those are missiles, guided missiles, as we can see in this illustration. Over 4,000 rockets were launched. The quality was lousy, so a quarter of them fell down in Gaza or in the sea. But over 3,000 reached Israel. So they needed to launch their missiles to take them out. Over 3,000 missiles. Imagine the cost. They took most of them down, but not all. And the point with this is, if a conflict or war lasts more than just a few weeks, you run out of everything. And you need more now, bigger volumes, cheaper, faster. And that's the challenge that we face most defense industries, not only from this conflict, but Ukraine is another one. Now, additive is one step towards automation, and that is needed in order to meet these requirements of higher volumes, faster delivery, and cheaper units. So additive has been important for Saab for many years now. We started about 9-10 years ago. And we had an assignment from the management team at Saab to collaborate between these different business areas that have such different product portfolios. So I have a Saab AM Group with people from aeronautics, surveillance, dynamics, and Kockums, and also the tech consultancy service, Combitech. And we collaborate, and our mission is to devise the strategy for Saab on additive and execute it. We drive the collaboration within the Saab Group, despite the different product portfolios. We develop Saab common solutions. There is no need to have different solutions just because we can. It's smarter for us to keep common solutions as much as possible. Disseminate knowledge. And we have another exhibitor here at Formnext is Amexi, which is a Swedish joint venture which Saab co-owns. And this group is also the point of contact for Saab people towards Amexi. And we are devising a Saab AM supply chain because we don't produce our metal parts in-house. Not yet. We will, to some extent, of course, but the strategy is now use suppliers. Our vision is that we go smarter with additive and improve our competitiveness by being innovative in all our products and processes. And we have some metrics on this. From 22 last year, we have 17 parts in volume production. Imagine how much that matters for Saab, but it's accelerating. But those 17 parts actually eliminated 636 components, and that's one value. And we have this little competition inside the Saab Group, who is the best on part reduction, buy-to-fly ratio, lead time reduction, weight reduction, cost reduction. It's going to be harder every year to beat that one. But it's some of the values that we see in these applications. We have lots of industrial polymer printers, no metal printers so far, so we rely on our suppliers. And I will just show you some examples of applications that we have. One of the first was actually a cool plate. To the left there, it's about this big. And on both sides, you have high power electronics, gallium nitride. And I mean high power. At the surface of the chip, you have a power generation that almost equals the surface of the sun. So if cooling fails, it burns immediately. So you have, and this cool plate is hollow. You have coolant running in, here spreading in the plate, picking up the heat and exits. It's just 4 millimeters thick. And this is an AM design, and the plates sit on a flow distributor, 4 of them in one distributor, and it's all printed in aluminum. Sorry, that was the wrong direction. Now, it used to be brazed. Brazing is always a risk on leakage, but this one is leak-proof. It's just one part. It's lower weight, which is of great importance because it's a flying system. And the best of all, it's a better cool plate. It picks up more heat than any previous cool plate we had. And you reduce pressure loss due to nicer channels and so on. And people came up with good, ingenious solutions that rendered 1 patent, which is also a value. And we have it in production, some 100 units per year right now. And it's an airborne system. Also, here is the one missile I showed in the beginning, the RBS-15 anti-ship missile. Here it's launched from a ship with rocket boosters, and we had a part screening project on that a number of years ago, trying to find some parts that made sense to print. And that is pretty hard on existing products because you're not allowed to change much. So it's not that easy to find good business cases. But we'll find the first on this product, and that is the front cover skin, which is on the leading edge of the wings. And it's 4 wings on each missile, so it's 4 front cover skins per missile. To the left here you can see the traditional manufacture. I mean, it was 2 stamped halves of aluminum, welded together manually on the back here, and then you riveted a bottom plate to that. In total, 17 components, including the rivets. With an additive design, we could make it as 1 part, but cheaper, lighter, faster, and with fewer parts, and actually improved quality, because manual welding, 3D printing beats that from a quality perspective. So we have better repeatability on geometrical correctness. And this one is now in production, will be delivered to the customer. It's not that an important part for that product, but it's the first. Then if we take a look at this one, you have an inlet to the gas turbine under the missile, and that's the next part here. It's an ongoing project, and we focus on production. Hopefully it will go to production. And this design is a double-walled titanium print. It's about this size in width. We have a carbon fiber version right now, which this printed titanium beats in every aspect. It's half the price for the carbon fiber version. We can make it faster, and it actually beats the carbon fiber in weight as well. And we have added some parts here that was originally built onto this air intake and made it as one part. And we have different configurations of the missile depending on if it's launched from a ship or dropped from an airplane. And those different configurations we can accommodate in the AM design very easily. And it's all, again, one part, reduce the number of parts. So hopefully we have this in production pretty soon. One other example of using additive is for building temporary parts, a battlefield damage repair approach. And here you see on the Gripen fighter, one hatch that sticks out, and that is the temporary part sitting there in polymer, nylon. And what's that good for? Now, if you have a fighter on a mission somewhere in the world, and you have to access the equipment under that hatch many times during the missions. It comes off, and it on, and off, and on. And the risk is when you take it off, and you put it there, someone runs over it, and you don't have a hatch anymore. So what do? Ground the airplane? Take a hatch from another plane, then you ground that one. So if we can have a container with some polymer production capability out in the field with a mission, we can produce very fast a temporary part while we're waiting for the original part to be manufactured and shipped, but we keep the mission going. Now, we didn't know if that was interesting, so we made it public and offered the Swedish tech newspaper to produce it, so that's a Swedish print that you see there. But we also called upon other media in our business, sorry, wrong again, and they all made nice articles about this one, and for us it was a benchmark that okay, it's interesting what we do, so let's move on. Then I have one new example, and this is for a AUV, autonomous underwater vehicle. It seems like it looks like a torpedo, but it is not. It's made for other purposes, like minesweeping or something like that. But you see the tail section here, the aft part, has been printed, and it's a big part. It was printed in an SLM NXG 600 machine, and I think it was a couple of millimeters left to the top of the build chamber. So we have here one version, which is actually the cast design, but now printed. It doesn't make much sense, but we wanted to do that and do it all the way with all the post-processing and so on, machining and surface treatment, as you see here, ready to be put on a vehicle and for testing. But we also made a sort of AM design, a first approach to AM design to make it lighter, and that one is 30% lighter than the original part, and it's a good thing for that vehicle because it's heavy in the rear end. I'm not right here. So this is also an aluminum part, and we can go down to 50% of the weight using additive and a smart design for additive. Shorter lead times for sure, and we have fewer components. You can fuse in brackets and things like that. And we have other smart designs that additive actually offers for a vehicle like this that I cannot disclose, but there opens a lot more new possibilities with additive to other design features that we didn't have before. Okay, to sum it up, I see some appealing values with additive, as I've shown you, but I call these ones the secondary values: lower weight, shorter lead times, fewer components, and lower cost. And that's where most of my colleagues fall for. But the great values lie in actually functional optimization, make a better product. And if we focus on making a better product, better functionality, using the full envelope of complexity that additive can handle, you don't have to focus on the secondary values. You will get them as you go anyway. But okay, fair enough. Let's start with the secondary values and make some traction on additive within the Saab Group. And eventually, at the end of the day, arrive at focus on making better products. And when we have trained our staff and hired people and already knowing additive, there is no limit to what we can do to our products using additive. So, thank you for your attention, and I made it.
Thank you very much. Yes, we have a couple of minutes for questions. If anybody has any, or if anybody would like to take the mic and ask a question.
Thank you for the presentation. Going down this additive road, are you going to allow your customers to also print your developed parts?
Our customers?
Yeah.
I think the situation is right now that we are actually driving this, making our customers aware of what we can do with this technology. Not the other way around, that they request it from us. So we need to assume responsibility for driving this technology and show to our customers how much better we can design our products.
Thank you.
Any other questions?
Hello, I heard about your presentation. It was really nice for us. So I have one simple question. Their reliability. How can you guys validate the reliability?
Sorry, I couldn't quite hear you.
How you guys validate reliability?
Oh, okay.
Do you guys support any standard first, or just fit?
I mean, we have currently one project running focusing on qualification of a number of AM alloys to a certain standard, MMPDS, for example. So we have titanium already completed. We're conducting a project right now focused on aluminum. But that's only for the material and surface treatment parts. But when we've done that fully, we have, so to say, paved the way for many other AM applications, because most of the time when you find an interesting application, the cost for verification and validation kills the business case. So that's an investment for the future, I would say, that we qualify some commonly used alloys for additive to pave the way for new applications that give value all the time. And then again, each and every part has to be qualified for its purpose, to its spec. So you need to rerun tests on, for example, environmental requirements and stress requirements and so on. But that goes anyway for any part.
Thank you.